Welcome in this new tutorial. In this tutorial, I would like to show you a really cool new feature which is available in Real Virtual 2022. So far, making transport systems like this with curves based on colliders was nearly impossible. And that's because the colliders made the moving goods shake, maybe even block it. So really nice constant transport was impossible. And based on this cool new feature, which we call Guided Transport, you can model it very easily. You can even use stoppers. I turn the stopper on. I even don't know if it's stopping like that. Just placed it like that. And even if the stopper is going up while the goods are moving, it's behaving in a very realistic way. Besides maybe the shaking a little bit if you move it in the center. But you won't be able to destroy the transport. Goods are really conveying and stop in the corners as they should. And by doing this, you can concentrate on building up your transport system without fighting against the physics in Unity. I've created a new scene for our tutorial and I prepared some CAD data. For example, this curve here, which has been imported via step. I downloaded the example data from the Bosch Rexroad webpage. Here you can select the components and download them as step data. So here it's already imported. If you would like to know how to import 3D CAD data into Real Virtual and Unity, you can check one of our previous tutorials. Doesn't look very nice so far, so first of all, maybe I'm adding some materials. So Real Virtual 3D prefabs materials, and let's make all of this using the selection window. And let's take this material, aluminium. Now it's easier to mark all the components. And maybe let's make the frame in a gray. So let's keep it like that for the moment. But still our project has nothing in, so it's just a 3D component without any physics and so on. For adding here now the ability to transport goods, we are having two options. One is that we extend the one transport surface by a guide line or a guide circle. We won't use that here because we are not having really a transport surface. We don't need any kind of surface animation. Another thing what we can do is, and I'm adding an empty game object for that here, is we can use so-called transport guided the so-called transport guided component. I'm adding it here, and you already see it here for demonstration purposes. I move it out. So this component has a defined height. More or less, it doesn't matter. It's just for visualization of the box collider. The thickness isn't really important. And a defined length of this transport component, and you can turn it to a circular or to a linear one. The beginning is the green sphere and the end is the red sphere. Everything what you need is created, so basically a box collider and the guideline itself. And this one replaces the transport surface, and also a drive is automatically there. And it's not acting like a transport surface, it's just like an overlay over 3D data. Let's check it, how it behaves just besides the component we prepared. And first, for doing this, I need something to transport on this component. And for doing this, I've got an additional CAD file. Let's check, it's here, this one here. So we need to make a movable unit out of that. So I'm first creating an empty game object. So 000, let's call it MU. I need to have source, not an audio source, sorry. A real virtual source on it. And on top of this, I need the MU script on it, like for every movable unit. And what I need, especially here for guided transport, that's something new. I need to use the guided transport for function, the guide MU script. So these three scripts are needed: MU and guided MU for the component to be moved, and the source for creating them. Let's add our imported component to this. And I'm making it 0, 0, 0 for having the pivot point which I need for the MU. And what I also should consider, I put this on the layer MU for everything. And here we need to have a box collider. No, at the end we don't need it. But we will put it a box collider on the layer MU. By doing this, the MU will collide on this bottom itself. For the transport, guided transport itself, I don't need a collider on the component because everything is working based on the raycast. So I can turn on the debug mode, but the debug mode will only show something if it's connected or already on a guided transport. So let's move the MU on top of it for just testing it. Let's put it aside here. And I'm checking my guided transport. So let's line if the drive is already turned on, forward in maybe 450 millimeters per second, and let's start the game. What you need to make sure is that you've got a rigid body attached to your MU. That's why I had this error message. So let's check. And as you can see, the goods are transported on this surface. If I would like, I'm doing that inside. For later, transferring it to, I can also add a curve here and transport guided to this, and this time a curve. Okay, let's place it here. I'm turning it. And the drive jog forward with 250 millimeters per second. Now the components are moving in the curve. So if I now want to move that inside of my component, I just need to adjust the placement and the of our guidelines. So I'm going to stop it. No. Let's stop it in the scene. So that will be the curve and our line. So I'm going to make this as an entry. If you really know the positions in relation to the but it seems to fit very well here. The 0, yeah, it's the surface, the standard coordinate system, and for the length, let's make it like that. The curve, also need to turn it, put it here, and from the radius, I don't know, maybe like that. And now we add another line, take this one to the end. We turn it, move it here. And that should already do the job. Let's take that, move it here. The X is always to the front, even if it would be aligned automatically. I'm just turning it like that. I just need to make sure that my raycast is hitting this green box. And let's see if everything, yeah, they are turned on, I think, yeah. And let's start. And you now see that it's already going smoothly through this system. The position is not as it should be, you see it here. So, but that's fine tuning. Basically, you've got a really reliable transport through the curve. For making out of this curve a reusable component, it might make sense to make it as a prefab. So if it's still blue, you should before unpack it completely. If it's not blue, so if it's somehow dependent from any kind of prefab, If it's like that, you can just drag and drop it in here. And now we are having a reusable prefab, which we're able to place anywhere. And for example, by doing this and turning it, we could the entry, we need to place the entry here, and it's, don't remember the height. Maybe let's take this to 0.3, everything. This also, okay, should be the same height. Ready. Place it here. And by using prefabs, we can easily build up systems. And let's start it. Here we go. Perfect. So for demonstrating stoppers, it might make sense to create one additional component, and that's a linear transport. Also, I've already imported it via step from the Brexroad website. I'm taking this one here, 0.3, and okay, that looks nice. Maybe we first change the materials. Can also use the material window here. And let's make maybe everything in aluminium, or in aluminium brushed, and the rollers in plastic black. And for having a transport component, I'm adding here also one additional component. Let's call it linear. And let's open the overlay menu back again. We add here also a transport guided. Not here on the controller. That was the wrong position. Sorry. So I'm removing it. I want to add this transport guided here. Need to select it before. Transport guided. 1 meter, it already seems to fit. Let's turn it on in standard with 250 millimeters. And this linear component, let's make out of it also a prefab. So first I unpack it completely for being independent from the base prefab of the CAD data, and I drag it here. Let's place it. What did I turn? Not the asset, okay. For the entry, somewhere here. More or less that does matters for the moment. And maybe one more for the exit. Here it is. and I'm going to turn the movable unit into the front, and let's check. It doesn't seem to be turned on, the drive. Am I right? The jog forward is not turned on. A good example we can now show, we can go to the prefab, so to the mother of all, turn on here jog forward, and now even the second one will have the drive turned on. And here we go. And as you can see, the goods are even stopped. I see something is disappearing. That might happen if there is empty space between the components. So we need to move this here. So the collider really needs to overlap. So it's better to make the guided service a little bit longer, because if our raycast is not colliding with anything, the goods might fall down. And now nothing is disappearing, and they are really blocked here, as it should be, by the movable units in front. Okay, perfect. So now let's try in creating a stopper. Also for the stopper, I've got a prepared component imported via step from CAD. It's here. And let's put it to 0.3. And it I'm not totally sure how it looks like. Okay, I think it's already out of on a higher level than the rules. What I'm going to do, I'm going to move this up and down. Even if I don't know in detail, it might be only a part of this component which is moving up and down, but because it's not separated into different objects, let's make the whole thing move up and down. So for using it as a stopper, maybe first let's give it a special material or color. So again, the material window, which makes it easier, and let's select that as red. Set this as red, and maybe the rest of the components, I don't know, plastic dark gray, set. So that will be our stopper. Maybe red, set. Yes, red. Okay, that's our stopper. And for acting as a stopper, it should have a collider. So we are adding a collider, a box collider, the simplest possible collider, and this should be on the layer transport, so that it's colliding with the MU. So let's see what happens if it's stopped and if the layer is, or the level is as it should be. and it's stopping it. Okay, only thing we now need to do is, as you can see, it stopped a little bit before because of the collider. We could adjust this and make it maybe just until here. Collider. To stop it. Okay, and for making it work, easiest way for doing it is adding a drive to it. This drive should go up and down. And for having a behavior model, I add a drive cylinder model to it. And the cylinder should go in min, maybe minus 50 millimeters and max 0 millimeters, and it should be a 1-bit cylinder, so controlled by only one signal. And I'm creating here one signal empty game object for the signals, and PLC output pool, open stopper, and on our stopper here on the cylinder I'm assigning this signal. So let's check if this is doing the job. Okay, it's not open, it's closed stopper, but as you can see, it's perfectly doing what it should do. And stopping the components, maybe once again, so it's called closed stopper. If it's true, it's closed. Once again. It stopped. The goods are aligning really perfectly. I can open it. I can even close it directly. Okay. And behaving as it should. Maybe the stopper was a little bit slow because it's 1 second time in and out. It's even unrealistic. So I will change it against this. If you turn on the gizmos, you see the guidelines and the colliders for our transport system. That's it for today. So a really, really easy way for modeling transport systems and still having a physical behavior. Really easy to use, and it's making things possible which have not been possible in the versions before with Real Virtual I/O. Thanks a lot. Please subscribe for our channel or all our LinkedIn stuff, our LinkedIn newsletter, and I wish you much success with Real Virtual I/O and have fun with it. Bye bye.